Okay, well, thanks for coming. My name's David Dunn. I'm a software engineer at Electric Imp. So, has anyone heard of us? Okay, good. We're involved with the Internet of Things Security Foundation, which a chap called Roger Shepherd's involved with. I don't think he's here today, but very wise. So it's through him that I've been invited today. I think I gave a talk back in November in Temple Meads, so I don't know if any of you saw me talking there, but I'm going to give a different talk tonight. So, this afternoon. Most people here developers. Everyone developers. So, what? Embedded developers, cloud developers, desktop developers? Okay, so what I've done is I've picked up some slides from my company's marketing folder, but I'll try and make them developer interesting. So when John invited me, he said people here would be interested in Internet of Things connectivity and security. So this is our strapline. So we don't consider connectivity separately to security at Electric Imp. We think you can't do one without the other and provide a decent platform. So what we are is a connectivity platform, and hopefully over the next few minutes I'll explain a bit more what that means. We provide secure connectivity so that product designers can design products. That product designers typically aren't internet developers, so we try and provide the bits that they're not expert at so they can get on with the things that they are expert at. So first of all, I'm going to talk. I'm going to tell you what we do, really, what our platform is, and really that's a story about connectivity. And then at the end, I'll do a whistle-stop tour of some of the things that we do, but we think everyone should do for security purposes with Internet of Things devices. Okay, so Electric Imp, who are we? So our founder is a chap called Hugo Fines, who's actually from this neck of the woods, from Somerset. He founded a company called MPEG in Cambridge in the 90s, which invented the first in-car MP3 player, so some of you may have heard of that. He went on from there to be the product lead on the new brand of iPhones, so he was at Apple for a long time. So around 2011, he was trying to set up some lights in his bathroom that would go different colours according to the weather or the stocks and shares or whatever. And he found it was very, very difficult to do something as simple as connecting lights to the internet. And it led him to think that he needed, or we needed, a platform which would make that kind of thing very easy. So he got together with Peter Hartley, who's my colleague in Cambridge, and they set about putting a demonstration together, trying to get some funding for a new venture. So in 2012, we got some funding, and we launched the platform. This is a bit of a timeline. It's a little bit out of date. This is sort of autumn last year. So we launched the Imp Cloud, then we launched the Imp Factory, which is how we manufacture devices. And then from here on, we've got products, real customers, real products. So one of the early ones was this thing. It's called the Red Light, and it's sponsored by Budweiser. So what you do is you sit in a room in North America or Canada, drinking beer, watching your favourite hockey game, and you teach the device which team you're interested in, and when they score a goal, this red light goes off in your room. So this was one of our early products, and there's been a lot of them sold, actually. So that kind of helps us to get going. This is the GE General Electric aircon unit, which is internet connected. So I'll talk a bit more about that in a minute. Cybex do gym sports equipment. Then private cloud. So all of these things run in a public cloud. Some of our customers wanted to have single tenant private clouds. So we launched that towards the end of last year. And then Pitney Bowes became probably our biggest customer to date, and I'll talk about them in a second. So this is just showing where we've come in the last 5 years. So 17 billion plus messages a month from devices to our cloud services. I think now over 1 million Imp devices and over 100 customers. So each customer obviously makes multiple devices. Okay, so here's some of our customers in a bit more detail. So Pitney Bowes, they make franking machines, so chances are if you work in an office, you've got one of their devices. In North America, they're backed by 56K modems, and AT&T are withdrawing support for those at the moment. So they needed a way of keeping those things connected. So what they've done is a retrofit using this box here, which has got our device in it. So it plugs in by USB to their device, and then it talks to the cloud via our device. So actually, for the purpose of this talk, this was really important for us because a franking machine is basically something that prints money, and it's subject to regulation and very stringent rules. So this kind of proves that we're doing the right things with security. Liberty Pumps, they're underground pumps, and Cybex, they do sports equipment, but they use us for similar reasons, which is in-field monitoring of devices. So typically somebody's supposed to go around with a checklist every few months and make sure the machine doesn't need any maintenance. These things phone home and tell Cybex when machines need maintaining. So this saves a lot of money in unscheduled repairs. So this is quite a big thing for us. And this is the GE aircon. So you can control it from your phone. You turn it on when you're on your way home and all that kind of thing. So that's 4 of our kind of industrial-ish applications. Here are a few home things that we do. This is a company called Haiku. So what this little device is actually a barcode reader. So when you're chucking your packet of cornflakes away, you scan the barcode, chuck the cornflakes away. If it doesn't have a barcode, you can speak to it and say apples. And it makes a shopping list for you, which you can read on your phone when you go into the shop. And actually, Waitrose, at least in the UK and some other supermarkets in Europe, have apps where you can order online. So you could order from Ocado with one of these. So that's quite a nice little app. Oops. That's the buzz red light I told you about. This is Lockitron. They make a mobile phone controlled lock. So this is a house lock or whatever. So there's a few of the devices that we've got out in the field at the moment. So I've got one of these here actually. We've always made these developer kits. So anyone can pick one up and develop devices for themselves or try and prove products. So I'll show you what's in here. So this is one of our original devices. If I can open it. So it's inside an SD card form factor, but actually it's one of our chips in here, and we use the pins for I/O. And then we've got a breakout board where you plug this in, and you can drive various peripherals which are on here. There's a pixel LED and some sensors, I2C sensors. So I'll actually do a demonstration of this in a few minutes after I've explained a bit more about the platform, so I'll come back to that. So that's a bit more about it. And we've got a bit more industrial strength development kit. So this is one of them, a Fieldbus Gateway. So this is to help product designers develop their products quicker. So there's a whole family of these, which we call the IOT Quick Start family. So if you go to our website, you can see what's on there. Okay, so this is our platform in a diagram. So let me try and talk through this a little bit. So here's some kind of product, and inside it's an electric imp product, which provides the connectivity for this device. There's a secure link between our device and our cloud services, which I'll go into a bit more detail in a second. There's Blink Up, which is a way of provisioning the device, which I'll show you in a minute. There's the factory process for manufacture of our devices, but also for customer devices with our devices embedded. And then from our cloud services, we can talk to the wider web. So this is how we provide connectivity. We provide a secure link between the device and our cloud services, and then our cloud services can talk to the rest of the internet in a secure way. Yeah, so like I say, the aim is we do all this stuff so that manufacturers can concentrate on designing the product, and we'll provide the connectivity for them. Okay, so this is an IMP module. This is our IMP 003, so our third one. So basically, it's a system on chip, and most of our modules have had an ST microelectronics system on chip inside them, which is based on ARM core technology. There's a wireless part with it, and you've got your IOs, and some of our devices have external SPI flash for storage on them. So that's basically what our bit of the hardware looks like, and this one in particular is made by Murata for us in Japan. Okay, this is my software engineer's view of what this thing looks like. So on the IMP, we run an operating system which we inevitably call IMPOS, IMPOS, which has an IP stack, so we can talk to the internet. We've got a hardware abstraction layer so that we can talk to the peripherals on the device. And we run a virtual machine for application-specific code. So again, I'll show you this in a bit more detail in a minute. So the manufacturer will write some code to drive the device through Squirrel running in the virtual machine. And we provide what we call a curated I/O for the device. So at the other end, there's our cloud services. So for each IMP, we have, sorry, I automatically call the device an IMP, which is our in-house way of describing them. So each IMP has a one-to-one correspondence with another virtual machine in the cloud. And that's backed with an IDE for coding, an ops console to monitor your company's devices, and open APIs can talk to the rest of the internet, like I said. So you can talk to your device back through your phone, for example. And the agent, of course, can provide HTTP endpoints and RESTful APIs so that you can talk back to the device through industry standard APIs. Okay, so we run an IDE. So this should be fairly self-evident. This is the device code. This is a language called Squirrel, which is a scripting language for games originally, I believe. But it's got a very small virtual machine, so it's very good for embedded coding. It's a C-style language, but it's got some functional type idioms that you can use with it. And then this is the Squirrel that runs in the agent on the other side. So when I demonstrate this, hopefully I'll show you that in action. If you don't like this, there's a build API as well, so you can compile with the favorite tools like Vim and whatever you want to use and push your compiled code up. So here's Blink Up. Let's hope this works. So it worked when I demoed it earlier. Here we go. So this is how we teach a device about the user account that it's associated with and the Wi-Fi credentials that it's going to connect to. So on your phone, you type in your SSID and password. You take your IMP. So the IMP's got an optical sensor on it, and the phone will flash a signal. And when it's done its business, the imp will flash green and it's connected. So that's how we provision devices.
Does that mean they have some sort of like unique ID?
Each imp has a unique ID, that's correct, yes.
It doesn't use a map or anything like that?
So we've got different devices and they have different methods. So some of them have ATSHARs on, for example, identity chips. But we use different methods. But each imp's uniquely identifiable. And it'll be associated with a particular manufacturer. So without going into too much detail, it'll only be allowed to run a particular code pushed by the manufacturer. Yeah. Okay, so to summarize all this, so we're adding the connectivity because that's the expensive and time-intensive bit. So you can't hire or expect a developer to do all this whilst you're developing your product. It's hundreds and hundreds of man-hours of effort to do all this stuff. So we provide a few of these things on here. Software security and updates, device to cloud security, provision and management, connectivity, support and maintenance, and approvals for the various Wi-Fi and stuff. So that's us in a nutshell. So I'm going to try now and do a demo of this thing. So if you just bear with me a sec. First thing I'm going to do is duplicate my displays. Okay. So you can see this. Okay, so I've already done this earlier. So when this device connects, I've told it to run this code already. But so basically, when you take this Explorer kit out of the box, it's like this. Plug the imp in. You can put batteries in, but I'm just going to use USB for power here. And you can see it flashes an LED code, which if you look at our documentation, that means it's got no Wi-Fi credentials on it. So I'll take my phone out. And I configure a device using the Wi-Fi in here. Okay, so start the blink up. Blink up TM. It seems a very simple way of doing it, but how do you teach a device your local Wi-Fi credentials? It's not a straightforward problem. So there we go. It's joining the network, and it's joined. And did we see hello from Imp Explorer? Okay, so that came in just now. So what's happened is this code's been pushed to the device and the corresponding agent code over here. So does anyone know about NeoPixels? No, it's this WS2812 thing. It's LED pixels. You can get them on strings and whatever, and you can program them using SPI. So we've got a library which can talk to WS2812 devices. So what this has done is the first line up here is just turn the thing on, made it using one of our pins, and then we've configured the SPI, most significant bit first, and the baud rate. We've instantiated a pixels object with 1 pixel in from the WS2812 class, and we've set that pixel to be 0. Which you can see on there. So I can hopefully let's change to green in there, say, and I can build and run the code. So remember that this is running on the internet, electricimp.com, and the LEDs come on green. So Okay, so the other bit of this is the agent code's got a request handler, an HTTP request handler. It's a bit clunky because I coded it up this morning. I just took this out of the box this morning and it joined the Wi-Fi nicely, so I thought I'd put this demo together. So basically it pulls a red, green and blue out of the query, and it does a device.send, which uses our secure link to come over to the device, and the agent's got a handler which corresponds to that one over there, and it'll change the color of the pixel. So I would have done this with curl, but I'm using Windows for the presentation, so I've just got a web browser here. So you can just see there's a red, green and blue value in each of those fields. So hopefully this will show low latency as well. Pixels change color. So it's a very simple demonstration, but that's the Internet of Things in a nutshell. There's a thing there connected to the internet, and we can talk to it. So that could have been a mobile phone app if I'd had the time to put it together. Yes?
Shall I ask now or at the end?
I don't mind if you ask now.
So that device is connected to your cloud?
Yes.
And because presumably you're on the Wi-Fi here,
Yes.
you're behind a firewall?
I don't know what the setup is here.
Or something.
There's a router, yes.
So is that polling your cloud? And how often does that happen?
It depends. There's a connection between the device and our server.
Yeah. And you're not pushing updates to the device, you're pulling updates? I mean, how does the communication work?
In that case, the agent, this line here is the important one, device.send.
Yeah.
So that goes back through our server over our secure protocol and into the device.
I got that much.
Sorry.
No, it's fine. I was just wondering in terms of TCP/IP.
Okay, it's a proprietary protocol on top of TCP/IP.
Okay.
So it's with SSL wrapped around it.
No, I'll catch it again.
Okay, sorry.
Some more questions.
Okay. So any more questions about this? No? Okay, I'll go back to the slides. So each agent's got a unique HTTP address associated with it, which let me bring it back up. Sorry, the agents, no, so the device has a virtual machine, and we call the corresponding virtual machine in the cloud, we call that the device's agent. It's historic terminology, I'm not sure it's correct, but so if I can just bring this one across here. Oh, I can't see what I'm doing. This one here. So this URL has got a unique identifier, and our cloud associates that uniquely with the device.
So it should come to be when the device is manufactured?
So in the IMP factory, it comes into being when the device is first commissioned. So. How am I doing for time? Okay. Okay, so here's another marketing slide. What I'm trying to get to here is security. So I'm probably going to talk about all the same things again, but talk about how we make all the bits of it secure. So it's this bit here, really, throughout the lifetime of the device. So security is really important. I'm sure you all know that. This is from Gartner this year. So they're saying, of course, that security is a challenge, but that device manufacturers aren't really ready for it, if you like. So like I said at the start, we take security very seriously. We've built our platform from the ground up with security rather than security as an afterthought. So we've seen Internet of Things manufacturers make a device and then think they can add security to it at the end, and it's been too late in some cases. So you've heard of the Mirai botnet. So this is a case, I think it was mainly CCTV cameras and things, but you know, if you can get control of things, you can set up DDoS attacks. There's been other cases where people have been able to telnet into insecure Internet of Things devices and gain access to people's home networks and whatnot. So the idea that you can make a product, start selling it, and then add security later is a fool's errand, really. So you need to build security into your platform. So this is a slide that my CEO talked about a few weeks ago. So people aren't always trying to get control of the device. They're sometimes interested just in the connectivity of the device. And the thing is, nobody's immune. So there's always security patches to SSL libraries and so on. So you need to be able to update your security as potential holes are identified. So it's more than just encryption. So this may be a caricature. This is maybe a traditional approach to making an Internet of Things device. So you take N vendors and you try and integrate everything together. This is what we've done over the last few years, which is to develop the whole platform and make every part of it secure. So from secure silicon right up to secure application integration with the cloud. Okay, so we think there's 7 layers of security that's important for IoT devices. So first of all, there's device security itself, which is secure silicon and managed software. So we don't want the device running software that isn't authorized to run. Data privacy. So once data leaves the device, we want that to be private. And we ensure that in several ways, which I'll talk about. Manufacturing needs to be trusted, and commissioning needs to be trusted. So that's our factory process. You need secure communication, which I spoke briefly about, between the device and the cloud. So I'll talk a bit about public and private clouds, but your cloud services themselves need to be protected. You need to have secure integration with other applications on the internet. I'll talk a bit more about that. And you need to think about security throughout the lifetime of the whole device, throughout the whole lifetime of the device. So that includes updates and so on. So I'm just going to go through these very quickly. I mean, a lot of this is stuff that people should know about. It's not rocket science in some ways. So edge device security. So we have HSM secure keys. So you have that whole ritual of getting 2 people to meet in a particular time and sign our binaries before we ship them. You need to have some secure boot process. So I think system on chips are getting wiser to this, actually. But you need to have ways of making sure that the device won't boot unauthorized code. So you need to build secure boot into your system. It's kind of the root of a chain of trust, if you like, secure boot. You need to disable your debug interfaces. Sounds obvious. So DFU, for example, is very useful for developing in the office. JTAG and all that stuff. Everything needs to be disabled on product release devices. All processing is done internally to the module. Unique per device key. So our factory provisioning process needs to give each device its own key. So even if you've got device A and device B, which are the same device physically, this one's private data can't be understood by this one. So, I mean, that's kind of, for example, if there's spy flash on them, you can't swap them over and read the other device's data. Strong encryption of data on the device. And I mentioned this briefly earlier. The application code runs in a virtual machine, so that there's a sandbox between the operating system and the application code. So our devices don't run native code from the application. Okay, data protection. So all off-module storage is encrypted. So if we've got a spy flash and users want to store their data in it, it's encrypted using their per-device secret. All in-transit data is encrypted from silicon to cloud. I've mentioned that before. So we use industry standard TLS for that tunnel. We don't store users' data, and we don't look at it. We don't even look at their code. It's up to the customer what they do with their data, but we don't sniff it or store it or anything. Okay, trusted commissioning. So there's 3 phases of commissioning. So there's manufacture, provisioning with blink up, which you've seen here. So the devices are provisioned in the factory to tell them, we call it a model, what model they're associated with, what customer and what code they're allowed to run, and then we commission them again when the end user gets them. So, and we call it enrollment. It's a replay-proof setup. So it's that. And securely managed in-field updates. So all of these things need updating from time to time. The operating system itself, there might be security patches, there might just be improvements in the way the operating system works. The customer might want to update their application code, and from time to time you might want to update the secrets in the field. Okay, secure communication. So we assume all networks are insecure. So we use TLS 1.2 encrypted links with forward security. Mutual authentication. So the imp won't talk to a server that doesn't have the right certificates and vice versa. We use AES 128 encryption. Maybe we'll move to 256 at some point. So this is what Hugo's fond of saying. You need to minimize the attack surface. So crudely, that means you need to minimize the number of ways in and out of your device. So we do that as much as we can. So that's why we talk only over the internet to a trusted server at the other end rather than everything. Random. So if someone's sniffing our traffic, which is of course encrypted, but we add random stuff into the mix as well. So what do we call it? Chaff. So just add an extra bit of confusion. Protected public and private cloud. So we use VPC architecture. So Amazon Web Services is what we run at the moment. Bastion hosts, good security policy and access control. The device communication link terminates at the endpoint in the cloud. No device keys are stored in the cloud. We build automated monitoring using things like Graphite around the system. So we get security alerts and downtime alerts and all sorts of things. So this has to cover end-to-end device security from provisioning right up to device updates. Okay, and yeah, sorry, 2 versions. So originally we had a public cloud service which all of our customers connected to, and it became apparent that some people wanted to have their own clouds. So we provide private clouds to some of our customers. So it's a bit of a challenge because we have to use different keys and so on, and different builds and different signings. And there has to be escrow and all this kind of thing in place for the private cloud. So that was quite a challenging aspect of our work last year. Secure cloud application integration. So the API that we provide for agents includes secure IP-based protocols, HTTPS. Recently we've done AMQP, which I just thought before this talk, I've forgotten exactly what it means. It's a message queue protocol, but it means we can talk to Azure, MQTT. It's another message queue transfer, telemetry transfer, I think. But for example, IBM Watson's based on top of that. So we're building in secure integration with other cloud service providers. And more to come. There's API support for application level security, so encryption and all that stuff. We provide APIs for so that you can send from the agent to the wider web. You can send secure. You can make secure links. Full lifecycle managed services. So, as I mentioned, this is ongoing platform maintenance and security updates. So it's really important to us that if we need to push out security updates, there's a rapid turnaround. And the slide I copied this from said near instant over-the-air in-field device updates, but we're all developers here. They're very fast. Okay, so that's all of my slides. So finished just about right, I think. Has anyone got any questions?
Can you interact it with your hardware learning the language, or is it just Squirrel?
So at the moment it's just Squirrel. Originally we used Lua, which was a little bit before my time, and it did their heads in for some reason. So Squirrel was good for the virtual machine size, although it might be less of an issue. But people have asked why we don't use Python, for example. We might introduce being able to run native code, but again, we'd have a virtual machine. And I think there's system on chips coming which are going to have proper hypervisor mode, so you can switch between kernel and user mode. So it might get safer to do that. But some of the companies we've worked with have got embedded engineers that have got decades of C code libraries, and they're loath to rewrite them in Squirrel. So it's a request we get quite often, actually. Can you provide C virtual machine or whatever? So at the moment, it's just Squirrel, though. Anyone else?
Another question.
Cool. Yep. Oh, sorry, I should have said.
Yeah, sure. Yeah, it was just about your developer box that you've got.
Yes.
Is that a kit? Is it just the one board, or is there more to it than that?
This one, it's I got this a couple of weeks ago before I went on holiday, so I've only taken it out today. This is basically designed for people to evaluate the platform. Okay. This one, it's got our IMPO 01, the original imp in it. But there's a whole family which we call the IOT Starter Kit, and they've got things like Modbus integration or Wi-Fi gateway integration. So depending on what product you think you might want to develop, they're quick starters for developing products. But you can get one of these and develop your own applications for fun at home. We've always done that. And we used, 4 years ago when I started the company, we used to go to maker fairs, and people were quite keen on building their own products with our devices. So that's definitely a part of our ecosystem. So if you're interested in getting one, I think they're available on Amazon. And I don't know the price of them. They're not very expensive.
Okay, thank you.
You're welcome.
Hi, I just wondered whether you use something like DNSSEC when you first initialize the board so that they can securely know who they're talking to.
No. We use standard TLS, so mutual certificate checking.
Do you embed this in the board?
Securely embedded, yes. Okay, thank you very much for coming.